Right now, as you watch this video, the universe is screaming. Somewhere out there, a pulsar is spinning at impossible speeds, generating sound waves so powerful they could shatter entire planets. And yet, just a few billion light years away, there exists a void so silent, so utterly empty, that not even a whisper of energy disturbs its cosmic stillness. Today, we're going to explore the most extreme acoustic environments in the universe, from the deafening roars of dying stars to the haunting silence of the darkest voids. Buckle up, because what you're about to discover will change how you think about sound, silence, and the universe itself. Before we dive into the loudest places in the cosmos, we need to understand something fundamental. Space is often called a vacuum, and technically that's correct. There's no air in space like we have on Earth, which means traditional sound waves can't travel the way they do here. But that doesn't mean the universe is silent. Far from it, sound can travel through plasma, gas clouds, and even the fabric of space-time itself. Scientists have developed ways to convert electromagnetic waves, radio signals, and gravitational waves into sounds we can actually hear. So when we talk about the loudest places in the universe, we're talking about regions where energy is being released at scales that are almost incomprehensible. Let's start with something relatively close to home, our own Sunday. The sun is actually incredibly loud. Scientists estimate that if sound could travel through the vacuum of space, the sun would produce a roar of about 120 decibels. That's equivalent to standing next to a rock concert speaker or a jet engine. Now imagine what it would sound like if you were actually on the sun's surface. The nuclear fusion happening in its core creates massive pressure waves that surge through the solar plasma. These oscillations have been recorded by spacecraft and converted into sound. The result is a deep, haunting hum that sounds almost alive, like the universe breathing. But the sun is just a warm-up. Let's journey deeper into space, to one of the truly deafening phenomena in the cosmos, pulsars. These are the remnants of massive stars that have collapsed into incredibly dense neutron stars. They spin at phenomenal speeds, sometimes hundreds of times per second, and emit beams of radiation from their magnetic poles. When these beams sweep past Earth, we detect them as pulses, like a cosmic lighthouse. The amount of energy being released is staggering. If we could hear a pulsar, it would create a rhythmic screaming sound, a relentless cosmic heartbeat pounding through space. Some pulsars spin so fast that their pulses create what sounds like a high-pitched shriek when converted to audio. It's the sound of matter and energy being pushed to their absolute limits. Now let's talk about something even more violent, supernovae. When a massive star exhausts its nuclear fuel, it doesn't just fade away quietly. It explodes in one of the most powerful events in the universe. A single supernova can briefly outshine an entire galaxy, releasing more energy in a few seconds than our sun will produce in its entire 10 billion year lifetime. The shockwave from a supernova tears through space at millions of kilometers per hour, compressing gas and dust and creating pressure waves that, if converted to sound, would be absolutely deafening. Scientists estimate that a supernova occurring at close range would produce sound levels exceeding 200 decibels. To put that in perspective, sounds above 190 decibels can kill a human instantly. A supernova isn't just loud, it's a cosmic scream that reshapes entire regions of space. But we're not done yet. There's something even louder than a supernova, and it involves the most mysterious objects in the universe, black holes. Specifically, we're talking about colliding black holes. When two black holes spiral toward each other and eventually merge, they create ripples in space-time itself, gravitational waves. These waves were first detected by the LIGO Observatory in 2015, and when scientists converted them into sound, the result was extraordinary. It was a brief chirp, a cosmic whoop-up that represented more energy than all the stars in the observable universe were emitting at that same moment. The collision of black holes is the loudest event we've ever detected, a literal ringing of the cosmos that echoes across billions of light years. Then there are quasars, some of the most luminous and energetic objects in the universe. At the heart of every quasar is a supermassive black hole, millions or even billions of times more massive than our sun. As matter spirals into these black holes, it forms an accretion disk that heats up to millions of degrees, emitting tremendous amounts of radiation across the electromagnetic spectrum. The turbulent activity in these accretion disks creates pressure waves in the surrounding gas. If we could hear these regions, they would roar with the sound of matter being torn apart and consumed. It's a feeding frenzy on a cosmic scale, and the noise would be absolutely overwhelming. Let's shift gears now and talk about something completely different, the quietest places in the universe. If the loudest places are defined by chaos and energy, the quietest places are defined by emptiness and stillness. The most silent regions in the cosmos are the great voids, vast expanses of space where almost nothing exists. These voids can span hundreds of millions of light years and contain very few galaxies, almost no gas, and virtually no dust. In these regions, there's simply nothing to create sound. No stars are exploding, no gas clouds are colliding, no black holes are feeding. It's the closest thing to absolute silence that exists in nature. One of the most famous of these is the Boötes Void, discovered in 1981. This region is roughly 330 million light years in diameter and contains only about 60 galaxies. For context, a typical region of space that size would contain thousands of galaxies. Standing in the Boötes Void, if such a thing were possible, you would experience a profound cosmic loneliness. The nearest galaxies would be so far away that they'd appear as faint smudges of light. There would be no stellar winds, no radiation pressure, no background hum from distant stars. Just silence. But even in these voids, there's not complete silence. The universe has a background noise, a relic from the Big Bang itself. This is called the cosmic microwave background radiation, and it permeates all of space. It's the afterglow of the universe's birth, cooled down over billions of years to just a few degrees above absolute zero. Scientists have converted this radiation into sound, and it creates a subtle hiss like cosmic static. So even in the quietest voids, the universe is still whispering its origin story. Another contender for the quietest place in the universe might be the space between galaxy clusters. Galaxy clusters are the largest gravitationally bound structures in the cosmos, containing hundreds or thousands of galaxies. But between these clusters, there are enormous gaps where almost nothing exists. These intergalactic spaces are even more empty than the voids within galaxy clusters. Here, the density of matter drops to nearly zero. If you could somehow exist in these regions, you'd be farther from any significant source of energy or matter than almost anywhere else in the universe. The silence would be profound, broken only by the occasional cosmic ray passing through. Interestingly, scientists have also discovered that sound waves can exist in the hot gas between galaxies in certain galaxy clusters. In 2003, astronomers detected sound waves in the Perseus galaxy cluster emanating from the supermassive black hole at its center. These waves have been propagating through the cluster's gas for billions of years. When converted to a pitch that humans can hear, the note is about 57 octaves below middle C, making it the deepest note ever detected in the universe. It's a cosmic bass note that's been playing for longer than Earth has existed. This brings us to an interesting philosophical question. If sound needs a medium to travel through, and most of space is essentially a vacuum, can we really talk about sound in the universe at all? The answer is yes, but with important caveats. While traditional sound waves like we experience on Earth can't travel through the vacuum of space, there are other forms of waves and oscillations that behave similarly. Plasma waves, pressure waves in gas clouds, and even gravitational waves all carry information and energy in ways that are analogous to sound. By converting these phenomena into audio frequencies, scientists can study them in new ways and make them accessible to our human senses. The contrast between the loudest and quietest places in the universe tells us something profound about the cosmos itself. The universe is a place of incredible extremes. Regions of unimaginable violence and energy exist right alongside vast expanses of stillness and emptiness. Both are essential to the cosmic story. The loud places are where stars are born, where elements are forged, where galaxies collide and merge. They're the engines of cosmic evolution. The quiet places, meanwhile, remind us of the vast scales involved. They show us that most of the universe is empty space, that matter and energy are actually quite rare when you consider the totality of existence. As we continue to explore the universe with ever more sophisticated instruments, we keep discovering new acoustic phenomena. Radio telescopes pick up bursts of energy from distant galaxies. Gravitational wave detectors listen for the collisions of massive objects. Space probes record the sounds of planetary magnetospheres and solar winds. Each new discovery adds another layer to our understanding of the cosmic symphony. So the next time you look up at the night sky, remember that what appears to be silent darkness is actually alive with sound, if only we have the tools to hear it. From the screaming pulsars to the silent voids, From the bass notes of black holes to the whisper of the Big Bang, the universe is telling us its story, and we're only just beginning to listen. Thank you for joining me on this journey through the loudest and quietest places in the cosmos. The universe is stranger and more wonderful than we ever imagined, and there's still so much more to discover.